water and hydrogen. In this topic, we will discuss some properties of water and hydrogen gas. The uses of water include drinking, washing, cooling, generation of steam to drive turbines, and as a solvent. In this subtopic, we will discuss some of the physical and chemical properties of water. Water is very important in chemistry. Water reacts with both metals and non-metals.
Water is a very important and abundant natural resource. Water occurs in rivers, lakes, oceans, rain, and wells. The products of a burning candle can be investigated by placing a well-lit candle on a stand and connecting it to a delivery tube. The delivery tube is dipped into a boiling tube, which is placed in ice-cold water. Another delivery tube is placed in a boiling tube containing lime water.
The candle burns in air to form a colorless gas that forms a white precipitate with calcium hydroxide solution. The white precipitate is calcium carbonate. The candle also produces vapor, which condenses to colorless liquid in the beaker containing ice-cold water. Attempt the following exercise.
The colorless solution formed is divided into two portions. To the first portion, anhydrous copper 2 sulfate. To the second portion, blue cobalt 2 chloride paper is immersed.
The change of color of anhydrous copper 2 sulfate and dry cobalt 2 chloride paper indicate that the colorless liquid is water. Water turns white anhydrous copper 2 sulfate blue. The colorless gas produced forms a white precipitate with calcium hydroxide. The gas is carbon 4 oxide. From the above observations, we can conclude that candle wax is made up of hydrogen and carbon only.
Some metals react with water. The experiment below investigates the reaction of sodium with cold water. Observe what happens when sodium metal is immersed in a trough containing cold water. Note the color of red and blue litmus paper. Sodium metal melts into a silvery ball, darts on the water surface, and gradually becomes smaller as the reaction continues. The solution formed turns red litmus paper blue, while the blue litmus remains blue. Therefore, the solution formed is alkaline. Sodium hydroxide and hydrogen gas are formed from this reaction.
A small piece of calcium metal is dropped into a trough containing cold water. A blue and red litmus paper in the solution are immersed in the water trough.
Calcium reacts with cold water to form calcium hydroxide and hydrogen gas. The solution is also alkaline because red litmus turns blue and the blue litmus remains blue.
Magnesium reacts with cold water very slowly to produce hydrogen and an alkaline solution of magnesium hydroxide.
The red litmus paper turns blue after a few days because the reaction between magnesium and water is very slow.
Zinc can also be placed in the boiling tube separately.
Zinc forms a yellow solid when heated in steam, which turns white on cooling. Zinc reacts with steam much more slowly than magnesium. Zinc oxide and hydrogen gas are formed. Iron also reacts with steam. Observe the following animation and note what happens. Red-hot iron reacts with steam to produce triiron tetraoxide, which is black.
Magnesium, zinc, and iron form their oxides and hydrogen gas. Aluminium is more reactive than zinc and iron, but it does not react with steam. This is due to a layer of aluminium oxide which is formed when metals are exposed to air. All these reactions show that metals react differently with water. Metals can therefore be arranged according to how they react with water. There is decreasing reactivity from potassium to copper. Some compounds that contain hydrogen include water, acids, and organic compounds such as wood, starch, candle, wax, and proteins. Hydrogen can be prepared in the laboratory using zinc granules and sulfuric acid. Zinc granules are put in a conical flask, and dilute hydrochloric acid is added into a dropping funnel. Copper sulfate is added to increase the rate of reaction. The gas is collected over water into a gas jar.
Zinc granules react with dilute sulfuric acid to produce hydrogen gas, which is collected over water. During the reaction, effervescence occurs. If the gas is required dry, it is passed through concentrated sulfuric acid or fused calcium chloride.
When a test tube containing hydrogen gas is inverted in a water trough, the water level remains the same. This shows that hydrogen is insoluble in water. When moist blue and red litmus papers are put in a gas jar containing hydrogen, there is no effect on the litmus papers. Therefore, hydrogen gas is neutral.
Hydrogen forms an explosive mixture with oxygen or air, and a pop sound is heard. This is the confirmatory test for hydrogen gas. During the reaction, water is formed. Hydrogen is less dense than air as shown below.
Hydrogen generated from the reaction of zinc granules and dilute sulfuric acid is passed through a U-tube containing anhydrous calcium chloride. The gas produced is ignited and a beaker containing cold water is placed over the flame. Hydrogen reacts with some metal oxides. When hydrogen gas is passed through a combustion tube containing a small amount of copper-2 oxide, which is heated, a reaction takes place. Anhydrous copper-2 oxide is also placed in the combustion tube.
During the reaction, copper-2 oxide loses oxygen. Therefore, the copper-2 oxide is reduced to copper metal. Hydrogen gas gains the oxygen and is therefore oxidized to water. Copper-2 oxide is therefore an oxidizing agent, while hydrogen gas is a reducing agent. This reaction is known as a redox reaction because reduction and oxidation takes place at the same time. When the experiment is repeated with lead-2 oxide, yellow lead-2 changes to red-brown on heating. When the reaction is complete, gray lead metal is left in the crucible. Note the color change in the animation.
Iron 2 oxide also undergoes a reaction.
The oxides are reduced to metals while hydrogen is oxidized to water. Oxidation is the addition of oxygen to a substance. Reduction is the removal of oxygen from a substance.
Hydrogen gas has various uses. Hydrogen burns in oxygen to produce a very hot flame with a temperature of 3020 degrees centigrade used in welding and cutting metals. This flame is called oxyacetylene flame. Click to play the video to observe how this flame is used.
Manufacture of margarine. Liquid hydrogen is used as a fuel for rockets. The manufacture of ammonia. Industrial manufacture of hydrochloric acid.
Hydrogen gas is used in weather balloons due to its low density.